About multiplying two binomials. So this is going to be the easiest one. Okay, what have I said so far? We're going to what? Multiply two what? What does that tell you? What's this going to look like? What's inside of this parenthesis going to look like? How many terms will there be? Just two, right? So I'm going to make it an easy one because I told you I was going to make this one easy. I'm just going to put something like x plus 3, right? And then I'm going to put something like x minus 2. Okay? So I'm going to make it really easy. How many of you already know how to do this? What do?
You had the like terms?
Nope, this is different. So let me show you from yesterday. Yesterday we had a problem like this. Is this a different problem? Yes, okay? This is what we did yesterday. We just added the like terms and your answer is what? 2x's plus 3, or plus 1, right? X plus x is 2x, 3 minus 2 is 1. Everybody with me on that? So that's what we did yesterday, right? But today, we're not adding or subtracting, we're what? Multiplying. And this is super important when you take a test. Because on this chapter, are you going to have some of these problems on there? Yeah. Are you going to have some of these problems on the test? Yeah. And if you go too fast, you're going to do all of them like this, even if they look like this. Or you're going to do all of them like this, even if they look like this. And you're going to get confused. So you really have to pay attention to whether there's a plus or minus between the binomials. If there is, like terms. If there's not, we're going to distribute like a distributor. Okay, like we just saw in the car. So what this says is I want to multiply. But what do I have inside the parentheses? I have an addition and I have a what? Subtraction. So I have to distribute multiplication over the addition and subtraction. Okay? Now, because they're back to back, it says everything in here has to get distributed to everything in here. I do that one at a time. Remember how we talked about breaking down problems? Making them simpler and not making them such a big, huge deal like teenagers tend to do. Break it down. Just distribute the first term first. And by distribute, what am I saying?
Multiply.
Multiply, right? I'm multiplying those terms to these terms. So first term first, then second term second, obviously. So I'm going to distribute, multiply it to those. So let's do that. What's x times x? What's your name? Ashlyn, what's x times x? X squared, very good. A lot of kids mess that up when they try and say 2x, right? That's adding like terms. Remember, we're multiplying. So the exponents, 1 and 1, these get added together and it becomes x squared. Okay? So when you're multiplying the coefficients, you're adding the exponents. Remember when we did chart of destiny? That's why we did that the first day. So we can figure it out when we get to these type of problems. All right, so we add the exponents, we multiply the coefficient. Okay, next one. These aren't even like terms, but can I multiply them? Yes, you can multiply unlike terms. You just can't add them. So what's x times negative 2? That's pretty easy. What is it? What's your name?
Me?
Yeah.
Cadence.
Cadence, what's that going to be?
X times 2.
X times negative 2.
That's negative 2x.
Yeah, just negative 2x. Again, pretty easy. Okay. Now I'm going to distribute the what? What haven't I distributed from the distributor cap? Think about this being the distributor cap, this being the engine. What do I have to distribute?
The 3.
I got to distribute the 3. If I only fire, half the cylinders, it's not going to actually fire. So I've got to make sure that I am distributing both things over the entire equation. So now I'm distributing the 3. So what's your name?
Me?
Yeah.
Jacqueline.
Jacqueline. What do I get when I distribute the 3 then?
3x.
3x minus what?
6.
6. Good. Now, a lot of kids stop right here and they think they're done. Are you done? No, I have to go back and do what I did yesterday, which is add like what? Terms. Okay, what's your name?
Aspen.
So what are we, Ashton?
Aspen.
Aston. Okay, so what terms are like terms that I need to add?
Negative 2x and 3x.
The negative 2x and 3x. The other ones don't have any like terms. So just those two are what I'm going to add. What do I get when I add them? X squared, what?
Minus 1x. I mean, plus 1x.
Plus 1x, because the 3 is bigger than the 2. Think about a number line. Positive 3 minus 2, I'm at 1. But I'm not going to put a 1, I'm just going to put an x. Minus 6. Is the 1 implied there? Yeah, it's implied. I don't have to write it. Remember, math people are inherently lazy. We don't want to write it. We want to write as little as possible. So that's my answer. I'm done. Okay, that's it. That's all I got to do. Pretty easy on that one, right? Okay, let's make it a little harder. Okay, now what? What's this? Identify it for me. Good, binomial. What's this? Trinomial. I've got to distribute a binomial to a trinomial. Okay, let's see what we get. Okay, what's your name? You.
Simeon.
What is it?
Simeon.
Simeon, distribute the 2x squared for me. All the way through. Tell me the 3 things I'm going to get as I... What am I doing with the 2x squared, by the way? Multiplying. Remember, whenever you distribute, you're multiplying. So, distribute there, Simeon. What do I get?
6x5 to the 5th.
What did he do?
Added the
And he should have multiplied the coefficient. So instead of 6, we're going to get what?
8
8. Good. And then x what?
to the 5th.
To the 5th. See, you add the exponents, but you multiply the coefficients. Remember, you always do something different to what? The coefficient than you do the exponent. Remember, we talked about that when we did chart of destiny. That's why we started with that. Because I knew we were coming to this, right? You've got to do something different with the coefficients than you do the exponents. If you add the exponents and you add the coefficients, you're going to be wrong. Okay? If I'm multiplying the coefficients and adding the exponents, I'm probably right. Right? That's what you do when you multiply. Multiply the coefficients, add the exponents. Okay. All right, go ahead, Simeon, do the next one.
2x to the 3rd.
Very good. And last one?
4x to the 2nd.
Good. That's it. Okay. Now what needs to be distributed? What's your name?
Alex,
Alex, what needs to be distributed next?
the 3.
Go ahead and do it.
Okay, 12x squared, or cubed.
Okay, watch. Everybody watch what I do right here. It makes your life easier. What did I do?
whatever lowest.
You could write it out here, right, and just keep writing it. But honestly, it's so much easier to just line up your like terms. Okay? It's way easier. Why do you think teachers put seating charts in alphabetical order? It's because it makes it easier to think about, right? That's just putting it in an order that makes it easier to think about. Then I don't forget which ones are like terms. I know I got them lined up. If this was a negative, it would still make sense. You see what I mean? It doesn't matter on the signs as much. So that's what I'm going to do. If I have a like term, I'm going to line them up. Okay? If not, I'll just do the best I can. What's the next one? Go ahead, Alex.
3x.
Notice this one. How come I wrote it over there?
Because I have like
There wasn't any like term to put with it, right? And then the last one, Alex?
6.
How come I put it over there? No like term, right? Okay. Now I'm just going to add these, and boom. That's why I like putting them that way. It makes it easier. So what do I get? Oh, add the like terms for us, and then tell me the answer. What's your name?
Me?
Nope. Yep.
Sam,
What?
Samantha,
Samantha? Can you add those for me?
8x to the 5th, 14x cubed,
Notice she didn't change the exponent there. That's important. Okay, add the coefficients. Don't change the exponent. Okay, next.
4x squared,
4x squared
plus 3x,
plus 3x plus what?
6.
6. Okay, not bad, huh? Okay, so even if there's a binomial and trinomial, it's not that much harder than the binomial. Now, some people have an acronym. Have you guys ever used acronyms before? You have. In fact, we did it just the other day when we used pedal. It's a word that helps you remember something, right? Has anybody ever played the piano or music? What is face? Who knows what face represents? What does it represent?
It's the notes in between lines.
Yeah, it's the spaces, right? F-A-C-E in the treble clef, right? What does every good boy does fine mean?
It's the notes, like the.
It's the notes on top.
It's the lines, right, of the treble clef,
Yeah.
right? So yeah, it's the line. So sometimes we come up with those sort of things like pedal, like face, like every good boy does fine, like please excuse my dear Aunt Sally. Those are called mnemonic devices or acronyms, right? The acronym is a word, and mnemonic device is a saying. That's the only difference between those. But anyway, we use those to do things. So there's a little bit of that can happen with this, but I don't really like to teach it. It's called FOIL. I don't like to teach it, and I'll show you why. FOIL is the first terms multiplied together. This is first. Then the what?
Inside,
Oil. How do you spell foil?
outside.
Outside. I, inside, last. Okay? The reason I don't like to teach that is this problem right here. How do you do FOIL? It only works for what? Binomials. Does distribution and explaining and understanding distribution, does that always work? Yes. You see what I mean? So I always just think of it as distributing. It's the same as FOIL anyway. So whether the book says do FOIL or whether the book says do that, it doesn't really matter, does it? Okay. So that pretty much walks you through that. Now let's do some little weird things just for funsies. Okay? Here we go. Something a little different. Let's change this. Okay. Find the shaded area. What formulas might you need? Area of a what? Triangle. We need to know what that is. Area of a triangle. What other thing might come in handy? Area of a rectangle, right? So let's just remind each other what these are. And if you want to put these in your notes, you can. If you've already got it down and you say, I already know what those are, don't write them in your notes. You got it. Okay. What's the area of a triangle? How do you find the area of a triangle? Who knows? It's half the base times the height, right? Base times height divided by 2. If you didn't know that, put it in your notes. If you already knew that, don't even write it. You got it. Okay. How do you find the area of a rectangle? Most of you already know this one. You probably don't need to write it. What is it? Length times what? Width or height or whatever you want to call it, right? Okay, that's it. What's the area of that whole big rectangle? What's the area of this whole big rectangle? 6 times 5 is what?
30.
30. Okay? What's the area of this triangle? The one that isn't shaded? Well, what's
30.
the base? How far is it from here to here?
10.
10. And what's the height?
6.
6. So what's 10 times 6 divided by 2?
30.
Well, that's 60 divided by 2 is 30. Okay? Oh, I did this really horribly. It can't really, oh well. So I should, but it didn't work out very good. Oh wait, I did this wrong, that's why.
Yeah.
This wasn't 5, this was what?
60.
Yeah, this should be 60, because the length was what? 10, there we go. Length was 10, and that's going to be 10 times 6 is what? 60. So what is the area of the shaded region? Area of the shade is 30. All I have to do is do areas. Okay, and that's all that is. Okay. Now, use that and think through this. What's the area of the shaded area? What's the area of the shaded area? Well, first of all, what's the area of the rectangle? What should I do? What haven't I called on today? What's your name? Yeah.
Caleb.
Caden?
Yeah.
What do you think I should do to find the area of the rectangle?
So you should do x plus 2 times x plus 6.
Can you do that?
Yes.
We just learned it today, right?
Yes.
Okay, so Caleb, distribute the x for me, if you will.
X squared. 6x.
Good. Okay. And then what needs to be distributed next? What's this guy's name? Oh, that's Simeon. Remember, what's your name?
Aspen.
Ashton, sorry.
No,
Aston, sorry. Aston. Will you distribute the 2 for me?
2x.
2x
12.
plus 12. Okay. Combine the like terms for me. What's your name? Blue shirt. Yeah.
Sadie?
Sadie. Combine the like terms. What will I get?
X squared plus 8x
Oh, 8x. My bad.
plus 12.
Plus 12. Okay, so that's that. What's this triangle? What is this height?
X plus 2.
X plus 2. I agree. What's this base? Now, really, I didn't need this, by the way. I just thought it'd be easy to do. Because really, all I need is the base. What is this? X plus 6 divided by what?
2.
2. Okay, so let's do x plus 6 divided by 2 times x plus 2. And then divide the whole thing by what? 2. Where did this 2 come from? The formula, right? Okay. Why is the formula for area of a triangle what it is? It's half a square. Think about it. Make a square. Draw a diagonal. Isn't that half a square?
Mm-hmm.
So the square is length times what?
What?
Width. The triangle is half that. That's how come it's half. So, I mean, it's not really that hard to remember that. But that's what that 2 represents. Where did this 2 come from? It represents the actual base, right? The actual base is x plus 6 divided by 2. Can I times this? Can I do this? Yeah, it's still not that hard. Okay. Do I have to have a common denominator to multiply? No. Let me ask you this. True? Yes, true. Okay. Is that true? What did I learn from that? Can I break this down to this with the same denominator? Yeah. So let's think of this as x over 2 plus 6 over 2 times x plus 2. Let's just do the top. You with me? I'm just doing the top part. Well, 6 over 2 is what? 3. Okay, now I'm going to do my distributing. Okay, so let's do my distributing here. What was your name again? No. You're Caleb, right?
No, Caleb.
Caden. Caleb, Caden. What's your name?
Me?
No, her.
Me?
Yeah.
Sam?
Sam? So Sam, distribute that for me. What will I get? What's x times x?
X squared.
X squared over what?
2.
2. So don't get freaked out just because there's a fraction. It's just over that. No big deal. Yes?
Can I use the restroom?
Yeah. And then Sam, distribute to the next one. What do I get?
2x over 2?
2x over 2, but that'll reduce to what?
X.
2x over 2. What happens with those 2's? They'll reduce, and it's just going to be a what? X. Okay? All right. Oh, geez. I got this one. This last one. What? Alex. Never mind. I got that. Simeon. Sadie. just said her name. I can't remember it. What was your name again?
Mine,
Yeah,
Sam,
Sam. That's easy. I have a niece named Sam. That should be easy. Okay. Sam. I forgot your name. Kate, no, it's Caden. And you are?
Sydney,
Sydney,
Ashley,
Ashlyn,
Jacqueline,
Jacqueline Ashlyn. I should be able to remember those now. Jacqueline, Ashlyn and Jacqueline, right? Okay. And Sydney and Sadie. Okay, I'll remember those. Okay, Sydney, distribute the 3 for me.
3x
3x
plus 6.
plus 6. Now all I have to do is combine like what? Terms. So I end up with x squared plus 4x plus 6. Oh, this one's over what? Over 2. Sorry, I didn't write that. That's it. That's the answer. How come that's the answer? Well, that is the triangle that's shaded. There's only that one triangle shaded, right? I really didn't need to do this part. I just wanted to show you could do that part, right, if you need to. All right, let's try, let me see if there's anything else that I need to go over. I think we're good. That is it. Okay, so the assignment, are you still filming? Okay. The assignment's going to be page 73, and you're going to do 4 through 44, 4K, 4K plus 1. 4 through 44, 4K, 4K plus 1 on set 2-2 on page 73. Okay? You can stop it now.